Hey guys, have you ever wondered how we figure out the exact point where an object balances? That point is called the center of mass. In this video, I will show you how to calculate it using a math mechanic problem in June 2013 paper 3. Here I'm going to explain the logic behind it and I'll give you tips to remember the method for your exams. So the question says, the figure above shows a uniform square lamina PQRS of side 2L meters. A portion of the lamina in the form of a square PXYZ, where X lies on PQ and Z on PS with PX equals to PZ equals to L meters is removed. Another portion of the lamina in the form of a circle of radius L on 4 meters and with center O, distance L meters from QR and L on 2 meters from RS is equally removed. Find the distances of the center of gravity of the remaining lamina from P, Q and PS. So this is actually our setup diagram where our center of gravity is actually located. So you need to represent our data in a table. So here we are going to have our shapes, our area, our weight, the distance PQ, the distance PS. So we are going to start with the square PQ RS. The area normally is side times side. So the side here we have 2L respectively. So we are going to have 2L times 2L, which is 4L squared. So the weight here normally we can record that lambda is equals to the mass over the area. If I want to have the mass, I'll simply cross multiply. My mass will be lambda times the area, and the weight is mass times the gravity. So I'm going to have area times lambda times the gravity. And in this case, our area is 4L squared times the lambda times the gravity. The distance from PQ to the center of the square PQRS, since the complete distance QR is 2L, so the distance from PQ to the center is actually L, and the distance from PS to the center of the square PQRS is still L. Taking the second shape, which is our square PXYZ, so our area is this side times side, where we are going to have L times L, which is L square, and our weight will be the area times lambda times the gravity. The distance of the square PXYZ from PQ will be L on 2, and the distance from PS of our square PXYZ will still be L on 2. Then now from the circle, the area of the circle is pi radius square, and our radius here is given as L on 4. So we are going to have our radius here as pi on 16 L square, and our weight will simply be the area times lambda times the gravity. So finding the distance PQ of the circle. Normally in the question says that the center O is distance L meter from QR and L on 2 meters from RS. So from RS, the center of the circle from RS is actually given as L on 2, and the complete distance RQ is 2L. So if I want to have the distance from the center of the circle to the point where I have PQ, I'm going to simply have 2L minus L on 2, which I will have 3L on 2. Then now the distance of the circle from PS. So the question is still telling us that the center O is distance L meter from QR. So from QR, I'm having a distance as L meter. So if my complete distance RS is 2L, that means the distance from the center to PS is still L. So that's center here is still L. So calculating now our remaining lamina, I'm going to have what? 4L square minus L square minus pi on 16L square, which is giving me 3 minus pi on 16 L square. So find out the weight. I will simply multiply the area times lambda times the gravity. Okay, the remaining lamina, the distance PQ is y bar and the distance PS is x bar. Taking the moment now, I will simply start by the distance PS. The moment now is what? Force times the distance. And here I will start now with my first force, which is what? 3 minus pi on 16 L square lambda g. So I'll multiply it with my first distance, in which my first distance will be x bar. I'll multiply it with my x bar will be equals to what? My force times distance minus force times distance minus force times distance. So we are going to have our first force here, which is 3 minus pi on 16 L square lambda g times x bar will be equals to 4 L square lambda g times L minus L square lambda g times L on 2 minus pi on 16 L square lambda g times L. So simplify correctly, I'll have my x bar as 56 minus pi L on 48 minus pi. Taking the moment to find now our y bar. So we are going to have still the same principle. I will multiply my weight, my force, times the distance PQ respectively, subtracting each. I'm going to have 3 minus pi on 16 L square lambda g y bar be equals to 4 L square lambda g times L minus L square lambda g times L on 2 minus pi on 16 L square lambda g times 3L on 2. Simplify correctly, I'm going to have my y bar as 112 minus 3 pi on 2 times 48 minus pi L. So hence my center of gravity x bar and y bar is given as follow. Thank you very much for watching my video. Please don't forget to subscribe, comment and share.